Okay, let's look at question number 11. Emily sees a ship traveling at a constant speed along a straight section of a river. She walks parallel to the riverbank at a uniform rate faster than the ship. She counts 210 equal steps, walking from the back of the ship to the front. Walking in opposite direction, she counts 42 steps of the same size from the front of the ship to the back. In terms of Emily's equal steps, what is the length of the ship? So this question actually is a motion problem, right? So we have a distance, time, and speed, right? So we know two typical type of motion problem. One is catch up, the other is meeting problem. Okay, so this actually the challenge part is they integrate both type of problem in one question. The first step is you can see the Emily walking to the front of the ship, right? That's actually just a catching up problem. The next step is return. So from the front of the ship, then go to the end of ship. So this actually is a meeting problem. You meet the end of the ship, right? Okay. So then we can use a typical equations word problem, solving word problem. So we can do that. But today I'm going to introduce you a very interesting solution use the proportion. Okay, so let's see what happened in the first step. It walk 210 steps. Then the relative, so remember when they move in the relative speed gonna be E minus S. E be the speed of the Emily. S gonna be the speed of the ship, right? They are relative motion speed, right? Okay. So then the second step, so there's 42 steps, and the relative motion speed, that's going to be E plus S. Okay, so let's look at the ratio here. Now, 210 over 42, which equal to 5 over 1. So which means we need 5 times longer to go to do this the relative motion a whole trip, right? So you can see that's going to be 5. We're gonna 5. We can call this t. This is 5t. So now you can see that's basically 5t times the E plus E minus S. That actually goes the whole trip, cover the whole trip, right? Whole ship. So that's actually equal to 1t times E plus S, right? So the same meaning is actually they are inverse proportion, right? So basically you can see that the same meaning as E minus S over E plus S equal to 1 over 5. That's the same meaning, right? Okay, so with this we can easily solve E and S, the ratio of E and S. So we multiply, we got 5E minus 5S equal to E plus S. Then we find 4E equal to 6S. We find E over S equal to 3 over 2. Right. So Emily, the speed is 3, then ship speed is going to be 2. Their ratio is 3 to 2. With this ratio, we can go back to look here. So we're going to focus on the second part. So in this time, Emily do 42 steps. Then how much the ship do? Right. So you can see that will be 3 to 2, which equal to 42 over x, right? So because their speed is 3 to 2, then if Emily cover 42, how much the ship cover? They are proportion. So easy to solve, x equal to 28. So actually, their relative motion in this case is just the length of the ship, right? So then 42 plus 28, the answer is 70. We have the answer A. Okay, let's look at question number 12. The base 9 representation of the number n is 27006000052 base 9. What is the remainder when n is divided by 5, right? So I think we already know the base. So the place value is depends on where it is, right? So you can see this one, the last digit is 9 to power 0, then 9 to power 1, then 9 to power 2, etc. That's place value, right? So then we can count the 2 actually place value is going to be 2 times 9, the place value 9 to power 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So 9 to power 10. So the total value is 2 times 9 to power 10. So next digit is 7, and then 7 has a place value 9 to power 9. So then we're gonna plus 6. The place value gonna be that's 9 to power 6, right? Okay. So then we have 5 times 9 to power 1. Then we plus 2. 2 times 9 to power 0, basically that's 1. So we're gonna find the remainder when these n, these are already changed to base 10, right? So this is base 10. Okay, so what is remainder when this divide by 5? So if we divide by 5, so then we can just find out what we have for this one, right? Part by each one for this, right? Remember 9 to power 10. So 9 is when this divide by 5. So that's actually this congruent to the remainder is 4, right? We usually use -1 to represent. So the modulo of 5, right? So this is the fact, right? Okay, so then actually we just use a modulo logarithm. So this is just like a 2 times -1 to the power 10. So continue we do 7 times -1 to the power 9. Right, so we're gonna continue do this plus 6 times -1 to the power 6 plus 5 times -1 plus 2. Right, so then we can think about this give us this is 2 plus this is a -7, then plus 6 plus -5 plus 2. Right. Okay, so I think these give us, you can see this multiple 5. We don't have to care about it. This is actually is 6 plus 6 plus 2, that's also 10. So we can cancel. This is -7. -7 is congruent to -2 congruent to 3. So the answer is 3 modulo 5. That should be the answer. Question number 13. Each of the 6 balls is randomly and independent paint either black or white. What is with equally probability? What is the probability that every ball is different in color from more than half the other 5 balls? So what this means? I think I just want you Pay attention to this. What it means, every ball is different in color from more than half of the other 5 balls. Right, so let's see, we have a ball. So this is white. So the remaining, we have 5 balls. 1, 2, 3, 4, and 5. So that's much different from more than half of this. That means that's going to be black, 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 at least, right? So then we're not sure this is black or white. Okay, so but if we choose one ball as a black, because every ball, so if we choose one ball black, so then we have these left, right? So this also differs from half of these 5, more than half of this 5. That's these 2 must be white, right? Actually, this is the same meaning. We have 3 white and 3 black. Okay, once you saw this, the probability just so easy, right? Because the probability equal to number of success over number of total possibility. So because we have 6 balls, each ball we have 2 options, black or white. Total going to be 2 to the power 6 different ways. And out of the 6 balls, we're going to find 3 white and 3 black. That simply just sticks to 3. Right? So we can see 6 to 3 is 20, then 20 divided by 64. So we're going to do a cancel 4. We got 5 over 16. So the answer is D. Question number 14. How many order pairs xy of real numbers certify following system of equations? X squared plus 3y equal to 9, epsilon of x plus epsilon of y minus 4 parentheses squared equal to 1. Okay, so this one is, I think, one of the very common topic in AMCs. Right. So this one asks you how many order pairs of real number. So this asks you the number of a solution, right? Not ask you solve it. So and also give you these 2 equation that actually we can graph them. We can use a graphing to solve. We just need to find the number of solution, not the exact value, right? The first one is very easy to find out. This is quadratic equation, right? So we can see not quadratic function. So this one we can put y on one side. So 3y equal to x squared minus is negative 3y equal to x squared minus 9. So then we have y equal to negative x squared over 3, then plus 3. Okay, so I think we can find the intercepts. So when x equal to 0, x equal to 0, actually this give us the uh, the vertex, right? When this equal to 0, give us vertex. Vertex actually is 0, 3. X equal to 0, this is that. So when y equal to 0, we find we have 2 solutions, that's x and y actually equal to negative 3 and positive 3. So this just occur like this. Right. Okay, so now what about second equation? So x value of x plus epsilon y minus 4, then squared equal to 1. Now, I think a good easy way to do that, we're gonna put on one side, we can do we just do a square root. So probably be fine. We square root both sides, we find this gonna be x epsilon x plus epsilon y, then minus 4 equal to positive negative 1. right? So we're gonna reorder this. We have two equations, either this absolute value of x plus absolute value of y equal to 5, or absolute value of x plus absolute value of y equal to 3, right? So this is a very typical equation we saw in the past, right? Actually, what we're gonna do if we want to graph x plus y, then we equal to a constant c, right? If we want to graph this number always positive, right? Positive greater or equal to 0. Then we will just using the example 3. So suppose we have 3, right? So then this actually we're gonna take about the absolute value. The good reason is the good ways to do the in the first quadrant. So quadrant 1. So if you for the first quadrant both x, y are positive, we're gonna have x plus y equal to 3, right? So then you're gonna have a curve like this. So then you do the second quadrant. So that's x be negative number, y be positive. That give you negative x plus y equal to 3, right? So that's actually give you this curve, right? So basically you do the four quadrant, you give this a diamond. Actually it's a square like, right? Okay, so if we saw this, so we can see we just graph this. So this one, we can see we just do this, there's gonna be a like this. Okay, so this actually give us 3 solutions, right? What about next one? Next one, we're gonna have a larger, we're gonna have 5. So this give us this shape, right? So I think we're gonna have 2 more solutions. So total together we have 1, 2, 1, 2, 3, 4, 5. We got a 5 solution. Question 15. A isosceles triangle ABC has AB equal to AC equal to 3 square root 6. And a circle with radius 5 square root 2 is tangent to line AB at B and to line AC at C. What is the area of the circle that passes through the vertex ABC? Right. This is a geometry question, so don't give you a diagram. So the first step, we usually draw a diagram. So let's draw a diagram. We have here is A, we have B and C. This actually is the equilateral triangle. We have a circle pass through the A and B, actually tangent AB and tangent AC, right? So this is a tangency, this is a tangency. So because the tangency, we usually just need to connect it. So that means this is going to be perpendicular. Right, so ABC is isosceles triangle, right? Okay, so we're going to mark this equal to this. All right. So, and also we can mark the length. The radius 5 square root of 2. The side length is the 3 square root of 6. Right. So we want to find a circle pass through these point, this ABC. And a very interesting pattern you should notice, because this is a perpendicular here. So actually, so these 4 points, so this opposite angle are net 180 degree. So this center O, A and B and C actually is on the same circle. Right? So this actually is on the same circle. So then we want to find what is the area of this circle. So because this right triangle, this actually is the diagonal. This just is equal to diagonal. All right. So now do you see the trick? Right. Yeah, so you already see this is right angle, this leg, we have diagonal. Diagonal actually is the diameter of this circle, right? So we can simply find the diameter. Diameter is equal to 2r, which equal to square root of 5 squared 2 squared, then plus 3 squared 6 squared. So which equal to, yeah, we just square both sides. I think we just 4r squared because we just need a r squared. So this side is 50. So plus this is 54. We have r squared equal to uh, this is 104 divided by 4. That's 26. R squared equal to 26. We want to find the area of the circle. The area equal to pi r squared. Then r squared equal to 26. The area going to be 26 pi. Question number 16. The graph of function x equal to absolute value of, yep, so you know this sign, x with these two signs, that's called flooring. So what flooring means? Flooring of x is the greatest integer not exceeding x, right? So the outside is absolute value minus absolute value of 1 minus x, then do the flooring. Is symmetric about which of the following? Right. So we need to know this. What is flooring first? Let's see if we have a number line. We put a 0 here. We put a 1 here. We put a 2 here. Then we have 3. We have -1, -2, and -3. Now we're going to look at start from 0. If we have 0, so 0, so that will be the same. That integer will be the same. So if I have integer flooring of 2, so that's equal to 2 itself. So let me write this. This equal to 0, and this equal to 2, right? Okay, so then I'm gonna put here, so maybe stretch a little bit, make more room to write. So let's see, this gonna be flooring. So 0 is 0, and I use a different color to tell the difference. 0, then this is gonna be 1, this is going to be 2, this is going to be 3, right? What happens if we have a number in between? So for example, some number here. So that flooring means you're going to find a number, the integer number just below this one. That's actually a 0. So if you have the number here, find the integer below this. That's going to be 1. So any number between 0 and 1 gives 0. Any number between 1 and 2 give you 1. And the number between 2 and 3 give you 2, right? So this is positive part. Let's look at this one. What about we have -1? If we have -1, that's integer, right? So this is going to be -1. And -2 is -2. -3 is -3, right? What about number between here? Between 0, -1 and here. If you do this, so this is going to be found integer below this point, right? That's actually is -1. So the between -1 and -2, so give you -2. Below -2 and -3 give you -3. All right, so now we're going to just look at what about this part, 1 minus x, 1 minus x. Let's just do this. So if I have 0, so 1 minus 0 is 1, then flooring, that's still 1, right? So a number between 0 and 1, so then suppose 0.5. 1 minus 0.5 is 0.5, your flooring, which actually is 0. So 1, 1 minus 1 is 0, then fluorine is still 0. Then we continue, we got 1.5, something like that. 1.5, then give you 1 minus 1.5. 1 more minus 1 point, the negative 0.5. You do the fluorine, which actually give you negative 1, right? So then we can continue this side. We have some number between 0 and negative 1, for example, negative 0.5. Negative 0.5. Then 1 minus 0.5 is 1.5. You do the fluorine, that's actually is 1. Right? So continue, we have negative 1, 1 minus negative 1 is positive 2, then do fluorine, that is 2. Right? So continue, some number between negative 1 and negative 1 and negative 1 and negative 2, for example, negative 1.5. Then this give you 1 minus negative 1.5, that's 2.5, then do fluorine, which is 2. Then negative 2, 1 minus negative 2 is 3, then 3 fluorine, that will be 3, right? That's basically what it is, right? So now we're gonna do the fx. So we're gonna do fx. Here we from 0, from 0, we're gonna do f's value of 0 minus f's of this, 0 minus 1, which is negative 1. All right, so this is a 0, negative 1. So we found for some number between 0 and 1. So that's going to be absolute 0 minus absolute 0. That will be 0. Then for 1, let's give you the absolute 1 minus absolute 0. Then that's 1 minus 0, which is 1, right? Let's do a couple more to this side, one more. So if we find some number from here, that is between 1.1, 1.2, between 1 and 2. So that's going to be absolute of 1 minus absolute of negative 1. That's 1 minus 1, which is 0, right? So if you keep doing that, so then we're going to have this next one, we're going to have 2 absolute of 2. This actually is as a round down, this is 2. I think that's 2. Then 1 minus 2 is a negative is negative 1. Then absolute value of this negative 1. Then 2 minus absolute 1, which is 1, right? So now basically you can continue. This can be 0, 1, 0, 1, 0, 1. Right? Look at this side. Some number between 0 and the negative 1. So we have absolute of this minus absolute of this. 1 minus 1, which is 0. So we're going to look at this one. This is absolute of negative 1 minus 2, which is 1 minus 2, which is negative 1. So we have this one, negative absolute of negative 2 minus absolute 2 is 2 minus 2, which is 0. Then absolute value of negative 2 minus absolute 3, that will be a negative 1, right? So continue, you can see this is going to be a 0 and negative 1, something like that. All right, so now we're going to just plot this part. So we're going to have a number line, a coordinate plane. We know when x equal to 0, that's equal to negative 1 here, right? So that's equal to, this is 0. When x equal to 0, this x, then the fx equal to negative 1. So then when x equal to some number between 0 and 1, give us a 0. So that's mark, this is 1. So these give us this part. So of course we don't have this 0. And when x equal to 1, that's give us 1. So we don't have this point. We have a 1. That's going to be this point. And for number between 1 and 2, go back to 0. That's going to be here. Then we have a 2. That's 1. So continue. Just give this part. Right. So what about negative side? Right. So we have -1, then from 0 to -1, that's all negative here. 0 here, right? From 0 to -1, we have the value is 0. And then when x equal to -1, we got -1. So -1 to -2, which are 0. When x equal to -2, that would be -1. So this is going to be the curve. So which one is symmetry? So I tend to look at maybe here, but actually you can see if you think about origin, so this symmetry to this symmetry to this, but actually this point has no symmetry, right? So actually we need to look at this. This actually is rotate about this point. So then they match each other perfectly. Right. So then we have the answer is D. Okay, question number 17. An architect is building a structure that will place vertical pillars at the vertices of regular hexagon A, B, C, D, E, F, which is lying horizontally on the ground with the 6 pillars, with will hold up a flat solar panel that will not be parallel to the ground. The height of pillars at A, B, C are 12, 9, 10 meters respectively. What is the height in meters of the pillar at E? Again, so this is the geometry. Let's try to think about what it look like, right? So we have a regular hexagon. Let's call this is A, B, C, D, E, and F. So now we just play this tilt in certain way. So here we're gonna have a 12. Suppose here B we have 9. Then we have 10 at C. Right. So the question asks us what a pillar at E. Yeah, you can imagine we have support 9 at B. So C is higher, A is higher, right? So actually C is 1 meter higher, A is 3 meters higher than B, right? So this tilt, actually B is the lowest, right? Then you can E gonna climb up to E. Right. So we're gonna look at it very closely, but basically, in this regular hexagon, we have a 3 pairs of parallel lines. For example, we have these parallel to these. If you think about from B to C, that goes up by 1. So these are parallel with the equal set length. So that means from here also increase by 1. Right? So if you look at this one, this from B to A, that's increased by 3. So that's increased by 3. So this parallel line from D to E also increased by 3, right? Okay, so actually another very interesting pattern. So we know there's a center, right? So we can think about, we start from B, so we go from here to A, so we got 12, right? So then next step, we're gonna go along this way. So, this actually, there's a few equilateral triangles here, right, cut in the regular. So this actually is the same as this. They are parallel and same length. So that means if you from A to the O, you're going to increase by 1. Okay, so now we start from O. So maybe we can continue. So let's see, we're gonna follow this. We're gonna do another this piece. So these two parallel these and the same length. That's going to be increased by 1. So then we reach D. Then D, we're gonna go along from to DE. So these just parallel to AB, that's increased by 3. So now we just count. So we're gonna start from A, 12 plus 1, then plus 1, then plus 3. So which equal to 17. Answer is 17. Question number 18. A farmer's rectangular field is partitioned into 2 by 2 grid of 6 rectangular sections as shown in the figure. In each section, the farmer will plant 1 crop, corn, wheat, soybeans, and potatoes. The farmer does not want to grow corn and wheat in any 2 sections that share a border. And the farmer does not want to grow soybean and potatoes in any 2 sections that share a border. Given these restrictions, in how many ways can the farmer chooses the crop that planted in each of the 4 sections in the field? I think we already look at see this kind of question last year when we talk about combination and permutation combination, right? So I think this one we can do pick up of any of these 4 crops in the first. This is the four options, right? So we can look at the adjacent or opposite, right? So I think if we do adjacent, that's going to be 3 different choice. We cannot be the one of these. Either if we pick a corn, we can not pick a wheat. So we have 3 options here, right? But this lead a much more complicated case. So we usually just do this the alternate. So we're going to look at this one. So if we have do this, so then opposite basically that's no restriction when we do this, right? So we can have total four different options. So now you can see if we look at these two rectangle, that's going to be 4 times 4, which is total 16. But actually look closely, they're not evenly work because they're going to do different case. So first case, these will be the same color. So that's going to be 4 times 1, right? So if these can be the same, that's equal to 4 situation, right? If they're different, that's 4 times 3, which is 12 different ways. So that's basically 2 different cases. We're going to look at if they are same. So we have here, they are same. So if these 2 are different, right? Okay, so in this case, suppose we have the corn and corn. So this box just cannot be wheat. Then this has the 3 options. Similar here, we have 3 options. Taken together for this situation is 4 times 3 times 3, right? Basically 4 times 3 times 3, so which equal to 36 ways, right? So then we look at these 2 are different. These 2 are different. So if we have these are 4, these are 3 different. That's already 12, right? 4 times 3, right? So let's just choose one of the keys. Let's say this be corn. So this be wheat. They're not the same, right? So you can see in this one, we cannot with corn because we have wheat here. We cannot have wheat because corn is here. So we only possible is either the soybean or potato. Similar is soybean or potato here. So there are two options, two options. So we're gonna times two and times two, right? So that's actually is true for all situations. If I change this to the soybean, for example, right? So cannot be this one cannot be either wheat or this cannot be wheat or potato, right? Only thing we can have either C or S, right? Similar here, this also C or S. That's cover all situations. But basically, these two have, no matter what you choose, once this is different from this, there are going to be two options here, two options here. So that's why we have 4 times 3 times 2 times 2. We'll find this actually equal to 48. So total, you add it together, 36 plus 48, answer is 84. Question number 19. A disk of radius 1 rolls all the way around inside of square of side length s greater than 4 and swipe out the region of area A. A second disk of radius 1 rolls all the way around the outside of the same square and swipe out a region of area of 2A. The value of S can be written as A plus B pi over C, where A, B, and C are positive integer and B and C are relative prime. What is A plus B plus C? Okay, so this is a geometry question again, right? So then we need to draw this diagram. So we have a square, this black square, the width side length is S. So we look at the first part, the first coin roll inside along this edge, right? So now you can see this, it's going to roll all the way to the top. Then you go this way. So basically that's going to be covered inside, give you this, this center square, right? But we cannot touch the corner. The corner is just this quarter, right? This quarter circle outside of this quarter circle. Right, so now you can see here, so we can find these actually, this silence is s minus, right, minus 2 minus 2, so x minus 4. The silence of the inner square is s minus 4. Right, so then we can find the area of the swept by uh, the coin, the disc inside the big the square, right? So that's gonna be, we're gonna use the square A equal to s squared, so the black box, right? So s squared, we're gonna minus the inner gonna be s minus 4 silence s minus 4 squared, so the area. Then we need to take out the corner part, right? Quarter part. So actually quarter part, you can see they have 1, 2, 3, such of these. Let's make a shape like this. So we have 4 such that the outside now covered with the center with circle. So basically that's gonna be the area of this box because this has a silence 2. In here we have silence 2 here, right? So that's basically the 2 squared minus the circle. Circle has radius 1, so that means it pi times 1 squared. So this is going to be the first area inside. So we can see this actually equal to, we can simplify. So s squared minus s squared and minus 8s plus 16. So we need a minus 4 plus pi. Then we can continue, get rid of the parentheses. We're going to cancel s squared. We're going to have positive 8s. Then minus 16 minus 4 minus 20, then plus pi. So that would be the inside, right? We're going to look at the outside, the blue part, right? Blue part basically you have the this you roll this way, so then you reach here. So at this corner, they're going to rotate. Rotate basically that's going to swipe this quarter, right? So this actually this going to be radius 2. So the diameter of this swipe this one from here to here, right? So then continue go every corner here. So that will be the shape. So if you look at shape, so I'm gonna cut here. This is a quarter circle with radius 2, a quarter circle, and we have a quarter circle here. We have quarter circle here. So now you can see the 4-quarter circle has area is pi times. Let's make a whole circle, right? Pi times 2 squared. Then we're gonna look at adding this four strap this box, right? So we're gonna find this actually is 2a according to the question, right? So then we can write 2a actually equal to the 4 quarters make a whole circle. That's going to be pi times the radius. This radius 2. That's going to be 2 squared. Then plus these rectangular box. This rectangular box. So each of them is a 2 times. So this silence s. But we have 4 of them. We're going to multiply 4. So this actually equal to 4 pi plus 8s. So which is 2a, right? So we can continue find a actually equal to 2 pi plus, so this is 2 pi plus 4s. So now you can see this is a, we can set up an equation with only one variable s. So we can write this is 2 pi plus 4s equal to 8s minus 20 plus pi. So easily find 4s equal to 20 plus pi. So plus 20 both sides, minus pi both sides, right? So we can solve s equal to 20 divided by 4 is 5 plus 1 pi over 4 is pi over 4. So we can look at ABC. A is a 5. B is the coefficient in front of pi, that's equal to 1. Then C equal to the denominator, that's 4. We have 5 plus 1 plus 4. The question is this, that's equal to 10. Question number 20. For how many order pair B and C of positive integer does neither x squared plus bx plus c equal to 0, nor x squared plus cx plus b equal to 0 has two distinct real solutions, right? So I think the some keywords you need positive integer for b and c, and then these two quadratic equation has two distinct real solutions. Neither of them has two distinct real solutions, right? If we look at from here, so that's tell us, right, but discriminant, right? So the discriminant must smaller or equal to 0, right? If it's greater than 0, there are two distinct solutions, right? If it's equal to 0, only one solution. Then if we have smaller than 0, that's no real solution, right? Okay, so follow this idea. So we find the first equation has no two distinct real solution. That means the discriminant b squared minus 4ac, a is 1, minus 4c smaller or equal to 0, right? The second one, similar, we have c squared minus 4b smaller or equal to 0. Right. So from here, so we need to find some conclusion from here, right? So one way we can do is we're going to solve b, and then what b squared smaller or equal to 4c, then b smaller or equal to square root of 4c, or which is 2 square root of c, right? Remember, so both b are positive integer, right? That's what we're going to do, count these. So then we look at the second equation. We have c squared smaller equal to 4b. Then we're gonna continue because b is smaller than this. So that means this is bigger, this is smaller. We can say we can just continue. That's gonna be 4 times 2 square root c. Or we just write 8 square root c, right? So we're gonna rewrite this c squared equal to smaller or equal to 8 square root of c. So this one actually can write as c to power 1 half, right? So then we just dividing c to power 1 half both sides. So we have c over 2 divided by c 1 half. So that's much smaller or equal to 8, right? Remember, c is positive. That's why we divide this without changing the sign. So then we simplify this. We simplify, we find c to power 3 over 2 smaller or equal to 8. We can solve c smaller or equal to, yeah. So basically how to do that, right? So this actually, we need to do this power, right? We need to do this power, 2 over 3. 2 over, right? So this simplifying we got 4. C actually is smaller or equal to 4. So this is the first very important information. So this is C smaller or equal to 4, right? So this is one way to solve, right? Actually, we have a 2 different solutions also find this conclusion. So basically what we're gonna do is we're gonna add this 2. We have b squared minus 4c plus c squared minus 4b smaller or equal to 0. So I'm going to look at the b squared minus 4b, then plus c squared minus 4c smaller or equal to 0, right? But actually, I want to make a perfect square. I'm going to add 4. I'm going to add 4. So then this side, and also add 4. So basically, that's we add a total 8, right? So I'm going to put the 18. So this is perfect square b minus 2 squared plus c minus 2 squared, then smaller or equal to 8. Right. So you can see here. So this one is greater or equal to 0. So when this equal to 0, actually gives the maximum. So basically b minus 2 squared must smaller or equal to 8 minus c minus 2 squared, right? So now you can see this gonna actually is definitely smaller than 8. So we can just say this definitely smaller than 8. Smaller or equal to 8, right? Okay. So then we can just continue this. We're gonna do the square root. So this b minus 4, b minus 2, just smaller or equal to 2 square root 2. So which equal to 2.8, about 1.2.8. So then b minus 2 must smaller or equal to 2.8. So then b smaller or equal to 4.8, right? And again, so b is a integer, right? So that means b actually smaller or equal to 4, right? So, b and c actually are symmetric, right? So we're gonna basically find either b or c actually both of them are smaller than equal to 4, right? But doesn't matter. We just have this idea. Then we just find. So we have this c equal to 4, c equal to 2, 3, c equal to 2, and we have c equal to 1. So we need to check this situation with, remember, b squared minus 4c is smaller than 0, right? Or smaller or equal to 4c. Or c squared minus smaller or equal to 4b. All right, so let's look at c. C equal to 4. C equal to 4. Then we're going to check b equal to 4. So this work. If we look at b equal to 3, so then this is going to be 4. 4 times 3 is 12. That's going to be smaller than c. So we have a small number b, that won't work, right? So basically we can just stop here. We find one solution with c equal to 4, b equal to 4. So continue, we're going to look at the c equal to 3. And of course, if b equal to 4, so that's going to be the same situation, right? So then we're going to look at what about b equal to 3. So now this equal, oh, this is smaller, right? That's a 9 smaller than 4 times 3. That's smaller than 12. Then 9 smaller than 4 times 12. Both could work. So let's see what about b equal to 2. So when we look at b equal to 2, so this is 9 smaller than 4 times 2. That's not true. So that's not good. So then we look at the c equal to 2. So we don't have to check b equal to 3, right? So we already saw 3 and 2. They are symmetry, right? So then we need to look at b equal to 2. So b equal to 2. So then that's b squared, 2 squared, smaller than 4 times 2. That's true. Then 2 squared, smaller than 4 times 2. That's also true. Then look at the b equal to 1. So then c, 2 squared, smaller than 4 times 1. That's true. Then b squared, that's 1 squared, smaller than 4 times 2. That's also true. This is good. Then we look at the c equal to 1. And also you can say b equal to 2 must be good. Right? Because we have c equal to 2, b equal to 1 here. By symmetry, we know this b equal to 2 is also symmetry. Then we look at the b equal to 1. B equal to 1, then c squared 1 smaller than 4 times 1. Then c squared, b squared 1, 1 squared smaller than 4c. Yep, both are correct. So now we have 1, 2, 3, 4, 5, 6. 6 solutions. The answer is 6.